Hello, my name is Dr. Brady Carter, and I have over 20 years of experience working with water activity and water activity instrumentation. In fact, I've used all types of water activity instruments, even a hair hygrometer. In my previous video, I talked about what are some of the pros and cons of each of the different water activity methods and tried to be honest about what makes each of those good and what are some of the challenges or the limitations of each method. And today I want to talk about why one particular instrument within all of those different types or methods I feel is the top of the line or the best water activity instrument available. And so I'm going to be doing a review on the LabMASTER NEO that's provided by Novasina Instruments. Now, in terms of what I look for and some of the specific key elements that I look for in a water activity instrument based on that experience and that interaction with all these kinds of instruments, there are several different key elements that I'm looking for and using as a way of scoring or judging a water activity instrument. And those include accuracy of the instrument, how much maintenance is required for the instrument and how difficult is that maintenance, how often does it need to be verified and how difficult is the verification process, whether or not the sensor itself has a hysteresis problem that can shift the calibration, the integrity of the chamber seal and how secure that chamber seal is, what are the stability settings that determine the end of the test, and are those adjustable? Can the instrument assure that you have true equilibrium or you have achieved true vapor equilibrium? Can it read volatiles and samples that contain volatiles and actually get water activity for those samples? Does it have temperature control? And how good is that temperature control? And then finally, how does it handle data and data control? And so these are the key elements that I'm going to use to judge and score the LabMASTER NEO. So today I'll be reviewing the LabMASTER NEO. So this is the LabMASTER NEO. It is the top of the line water activity instrument available from Novasina, a Swiss-based manufacturer of water activity instruments. I'm going to be reviewing it for all of the elements that I identified and giving it a score basically from 0 to 10 for each of these key elements. This water activity meter uses an electrolytic sensor to measure water activity. So as with any instrument, the way to measure water activity is you place a sample into the instrument, and then when you close the lid of the instrument, it seals that sample in and allows it to come to vapor equilibrium. And inside of this chamber, there also is a sensor, and it can be seen here in the instrument. The sensor is protected behind a filter or screen, so it's isolated away from the chamber. And that sensor consists of an electrolyte or electrolyte solution whose electrical properties will change with humidity, and so that change in electrical properties will provide the water activity of the sample once you've reached vapor equilibrium. So very simple in terms of measurement. Samples placed in, the lid's closed, you push the button, and you get water activity. No special setup, just plugs into any normal wall outlet. Can hook up to a computer, but also has internal storage. So just in terms of use, a fairly straightforward instrument. So the first key element that I identified as being critical for a water activity is accuracy. And accuracy is how capable is the instrument of being able to generate the correct answer. And the accuracy that's reported for the LabMASTER NEO is plus or minus 0.003 water activity. And that's the highest accuracy level in the marketplace for water activity instruments. So there are others that have similar types of accuracy, but that is the highest accuracy that's available in the marketplace, and the NEO is able to achieve that type of accuracy. Now, there is a critical distinction here between accuracy and precision, another term that often gets used for instrumentation. And accuracy, of course, is did you hit the bullseye? It's whether or not did you get the right answer. versus precision, which is basically the grouping. Did you get the same answer again and again? So an instrument can be accurate without being precise. It can also be precise without being accurate. With water activity instrumentation, we're able to determine accuracy of whether or not it gives the right answer by comparing the results, testing results from a water activity instrument to the known water activity of salt standards or salt solutions. And so we can determine and actually do a measurement of accuracy, and that's where that 0.003 number comes from, is a comparison between the measured value and the known value and how different are those values. And so for the LabMaster NEO, its accuracy, plus or minus 0.003. Its precision, plus or minus 0.002. So every reading, regardless if it's accurate or not, will be within 0.002 of each other if you keep reading it again and again. So in terms of accuracy and precision, because it has the highest level available, the LabMaster scores a 10 out of 10. So the next key element I want to talk about in terms of water activity instruments is maintenance. And this is a big one because in order to be able to use these instruments and have them give good readings and accurate readings, they have to be maintained and they have to be kept in good working condition. So the real key to the success of the NEO, and one of the key attributes, is the fact that this electrolytic sensor is protected behind the screen. So this sample, when it's in here, doesn't have any ability to be able to contact that sensor and interfere with its readings. And so because of that, the sensor has access to the headspace that's in common with the sample, but it doesn't have any contact with it. And so there's no chance, even after repeated use, to get anything up in there that's going to interfere with the sensor. Now with a chilled mirror system, one of the biggest challenges of using a chilled mirror, which is the main other method for measuring water activity, it does that by identifying a dew point temperature off of a chilled mirror. And the challenge there is that mirror, in order to be able to give good accurate readings, has to be clean. And it sits in the chamber with the sample, and so there's always the potential for something to get onto that mirror, whether it's just a small little bit of material, a streak of fat or oil that gets on there. It will interfere with the reading and cause the readings to not be correct. And the only way to know if that's happened is you got to read a salt standard and check it. And then you have to clean it if it's not reading correctly. And that has to be done frequently in order to be able to keep the machine going. With the electrolytic sensor being protected, the LabMaster NEO requires very little cleaning. It's able to stay stable and keep reading the verification standards correctly. So rarely would you need to do any kind of maintenance or cleaning with this. You can verify it weekly and probably just wipe it out every once in a while to make sure that you don't get the buildup of a lot of contaminants. So in terms of maintenance and the ease of maintenance, the NEO scores 10 out of 10. So the next key element that I want to discuss in terms of the water activity and judging water activity instrumentation is the ease of verification and how difficult that process is. For the LabMaster NEO, the way that it does verification, and again, the reason why you have to maintain the instrument is to make sure that it's performing the way that it's supposed to. The way you determine if it's performing the way that it's supposed to is through the use of salt standards. And there's essentially two different types of salt standards. There's saturated salt solutions that have known water activities based on the type of salt, and there are unsaturated salt solutions, and those are water activities known based on concentration. And so both are available. The advantage of the saturated slurries that are offered by the Novasina system is that they are reusable. So these come in a container. Inside you'll find one of these saturated salt slurries. These have up to 3-year shelf life. They're reusable, so you don't have to keep purchasing them again and again. So they aren't a consumable, and with an unsaturated salt solution, that is a consumable, and so that cost can add up, and it can be even as high as up to $65,000 per year just in salt consumable costs. Whereas these are reusable, they are good for up to 3 years, so you're not incurring that repeated cost. So in terms of verification, it's a real simple process with the NEO. It even has an RFID ID chip located right in the instrument. You just take the salt solution, present it to the instrument. It recognizes what salt solution that is, asks you if you want to verify or calibrate. So that whole process is automated. It's impossible to get the wrong salt or think you're using one salt versus another. So a very simple process as far as being able to quickly do a verification and using reusable salts. So from a standpoint of ease of verification, the NEO scores a 10 out of 10. The next key element in terms of water activity performance that I want to discuss is sensor hysteresis. And the reason why this is important is because it can have an impact on the quality of readings as well as on how frequently the instrument needs to be verified. So sensor hysteresis is, hysteresis means that something doesn't wet and dry to the same point. So in other words, if you approach a position coming from the wet end versus the dry end, it'll give a different answer. And the way that this impacts water activity readings is because if you have a sensor that experiences hysteresis, that means that every time you go to the high end of water activity and you come back down to the low end, the value at that low end is going to have shifted because of that memory or that hysteresis that's happening in the sensor. So that means that every time you have a wet up cycle and then every time you come back down, there's going to be a shift in the calibration of the water activity reading from a hygroscopic polymer. So these are the types of sensors that are most sensitive to this problem is any water activity system that's based hygroscopic polymer based. And this is how typically most relative humidity sensors that are just used for environmental sensing, that's how they're made, is they use a hygroscopic polymer and they measure the electrical properties of that polymer to determine what the changes in relative humidity are. And that can also be used for water activity determination because, again, you're measuring the relative humidity in the sealed chamber. So some systems use that same hygroscopic polymer, but it is sensitive to hysteresis, and so it has to be verified frequently, and the calibration has to be adjusted frequently if you are going and taking readings across a wide range of water activities. Now, the electrolytic sensor is unique in that it is measuring the electrical properties of that electrolytic sensor, but it does not experience hysteresis. So the electrolytic sensor is very unique in that sense. Sometimes it gets grouped with the hygroscopic polymer sensor in that all electrical based sensors have hysteresis, and that's not true. The electrolytic sensor in the NEO does not suffer from hysteresis. And this sensor has been in use and used for over 60 years. So the understanding of its properties are very well known, and that's one of the big reasons why it's so stable and it has that high stability and doesn't require the frequent verification is because of the perfecting of that sensor over the past 60 years. So in terms of sensor hysteresis, the LabMASTER NEO scores a 10 out of 10. So the next key element that I want to discuss in terms of water activity performance is the integrity of the chamber seal. So again, keep in mind that the way to measure water activity is to achieve vapor equilibrium. And so that's a key part or a key step in the water activity testing process. And so in order for that to happen, you have to have the sample in a sealed chamber. And as you can see on the NEO, it has a nice O-ring that sits around and closes against the chamber, and that O-ring creates a completely tight seal so that you won't have any kind of drift or change over time. And so when this comes down and you close that, it seals up against that chamber and keeps that chamber completely sealed. And this can be verified if you were to take a crystalline material, which will change its water activity to match room humidity very quickly. And if you place that, or you can use desiccant, for example, and you place it inside of the chamber, and it's in an environment where the room humidity or the environmental humidity is very high, then there's the possibility that humidity is eventually going to get into that chamber if the seal isn't tight and complete. And so if you watch that over time and you can let the system run for hours, what you'll see is that once it's flattened out or equilibrated, that there will be no drift over time. And in other types of instruments for water activity, you can see that drift. But the tightness of that is the best, the tightness of the chamber and the seal in the NEO has been verified as being the best available of any instruments. And this has even been verified by large food manufacturing companies. So in terms of integrity of the chamber seal, the LabMASTER NEO scores a 10 out of 10. So the next key factor I want to talk about in terms of water activity instrumentation is the ability to be able to adjust the determining step or factor for equilibrium or reaching vapor equilibrium that then ends the test. So all water activity instrumentation measures water activity by achieving vapor equilibrium in the chamber and then measuring the vapor pressure inside that chamber, or essentially the relative humidity, equilibrium relative humidity in that chamber. And so they all require that vapor equilibration step. And that time that it requires to reach vapor equilibrium is set by the matrix of the food. It's the food type that dictates that. It can't be artificially sped up in the instrument. That step takes the amount of time that it takes, and again, that's constant for that type of product. So if you have a product whose water activity or vapor equilibrium process takes 20 minutes, then it's going to take 20 minutes to read water activity. The only way you can speed that up is by doing a prediction or an estimation earlier than when you've achieved true vapor equilibrium. So in order to be able to achieve true vapor equilibrium, you have to have the capability to be able to adjust the stability settings that indicate the end of the test. Because if that end of test, and that's usually determined by the rate of water activity change, and when that rate of change falls below a certain value, that's indicative of having reached equilibrium. Some systems determine that by looking for a very specific difference between one water activity test and the other, and achieving that once. And if it achieves that, it ends the test. And the problem with that is that you can randomly achieve that kind of difference if it's not forced to achieve it multiple times. In the NEO, the stability settings are a little different. They require achieving a certain difference in water activity over a certain time. So that within that time frame, you can't have any difference greater than that controlled value or that set value. And so you can adjust the time that is required to meet that difference. So if you extend that to a longer time and make it more stringent, that is going to extend the test time, but it assures you of vapor equilibrium. And by how much it extends that test time is determined by the matrix of the sample. So it's important to be able to adjust those settings, because each sample type is going to be ideally associated with a different stability setting. And this is even recognized in the new ISO method. ISO 18787 actually puts a requirement on what that stability setting is. And because the NEO can adjust that stability setting, it's able to match that standard or any other standard in terms of what the stability requirements are. So if you want it to be fast, you want a quick result, you can do that, but you can also set it to very stringent values to make sure you achieve true vapor equilibrium. So from that standpoint, in terms of adjustable stability settings, the LabMASTER NEO scores a 10 out of 10. So the next key element I want to discuss in terms of water activity instruments is the ability to be able to detect and achieve true vapor equilibrium. Again, true water activity values depend on and require the achievement of vapor equilibrium, and that's matrix dependent. It's dependent on the food, and so you can't artificially speed that up. And so you need to have a system that can identify when that true vapor equilibrium has been achieved, so that you know what the actual requirements are in terms of test time. And then if you're going to make adjustments and try and speed that up, you also will know what will the consequence be of that. What type of error are you introducing by ending the test prior to having achieved true vapor equilibrium? Whereas other systems just end the test. You don't have any idea. Well, you have to accept that, well, I guess it's achieved vapor equilibrium and it's finished. What you might find, though, is that if you keep running that test again and again in that instrument, it'll continue to change because the vapor equilibrium process is still continuing. It hasn't been fully achieved. The nice thing in the LabMASTER NEO is that on the screen it has a graphing feature right on the screen that will track the equilibration process. So as the water activity reading is proceeding, you'll see those water activities go up, and then you'll see them flatten out as equilibrium is achieved. And so you know by looking at the graph when you have achieved true vapor equilibrium. And so if you were to set the stability settings to a less stringent value, it will identify the point where that is met, where it meets those requirements. And if you don't open the instrument up, it will continue to read and track water activity even after those stability settings have been met, which means that you can set it to a fast stability setting, run the test, see where it ends, and then let it keep going and see how much error you're introducing by ending the test when it did off of that fast technique or fast mode. So you can see what the value would have been there, and then see what it would be if you waited, say, 20 more minutes and you achieve true vapor equilibrium where that curve flattens off. Now, for some samples, there may not be a lot of difference. You may achieve vapor equilibrium in that amount of time, but others take a long time, like powders and high-fat samples, and other types of products where it's really important to know that you're getting the true equilibrium value. Once you know that you are and you know what that is, then you can make educated decisions about how you might speed up that test, and are you willing to speed it up and know that your value could be off by maybe 0.005 or 0.006 water activity. And if that's acceptable, that's fine. But the key is to be able to know what the true vapor equilibrium is. And the LabMASTER NEO lets you be able to do that, and because of that, it scores a 10 out of 10. So the next key element in terms of water activity instrumentation I want to discuss is the ability to be able to read volatiles. So different kinds of samples have and contain volatiles that will volatilize at room temperature, similar to water going into the vapor state. And when those volatiles are present, they can interfere with the water activity readings in different ways depending on the system you're using. These volatiles in a chilled mirror system will co-condense on the mirror and interfere with the reading and the ability to measure the dew point temperature. With the hygroscopic electrical hygrometers or with the electrolytic sensor, those volatiles can be absorbed by the sensors themselves, either the polymer or the electrolytic solution or the electrolytic sensor. And when that happens, it can shift the calibration. In a sense, it poisons them and can cause their calibrations to be permanently shifted. So volatiles do present a challenge. But in terms of the LabMASTER NEO, one of the nice elements of the design on this system is that with this sensor being isolated from the headspace and up and behind that filter, it makes it possible to incorporate other filters in front of that sensor, between it and the headspace. So when you're dealing with volatiles, with the LabMASTER NEO, you'll incorporate a filter that's key or specific to that type of volatile and place it in front of the sensor, and it will filter out any of those volatiles and prevent it from getting to the electrolytic sensor and protect it, which makes it possible then to read the water activity of even samples that contain volatiles. Now, the filter being in place does increase the path length in terms of water movement, so it can extend the time for the test to take, but it does give you the capability of reading the water activity of samples that contain volatiles, where other sensor systems with hygroscopic polymers or with the chilled mirror just simply can't read those types of samples. They don't have any way to read them. So it's either take a little bit longer or not read them. And in this case, the NEO can read the water activity of volatile containing samples with the filter system in place, and do so accurately with the same accuracy as it does any other type of a sample. And so because of that ability to read volatiles with the filter system, the LabMASTER NEO scores a 10 out of 10. The next element I want to discuss in terms of water activity instrumentation is temperature control. So water activity is temperature dependent. As you change the temperature, so will the water activity change. And so one key element of water activity testing is to control temperature. And in fact, water activity, when it's reported, needs to be reported with a temperature, the temperature at which it was measured. And so not having temperature control in the instrument can be a real problem, because as the conditions where the instrument is held fluctuate, an instrument not temperature controlled will just fluctuate with those temperatures. And that means you can have inconsistent readings throughout the year. So a key element of the LabMASTER NEO is it does have temperature control. In fact, it has the widest range of controllable temperature available in the marketplace. It can control from 0 degrees C up to 60 degrees C. So there's a wide range of temperatures that can be used with the system. Other reasons why you would want to have that range is because it's important to understand what the water activity response is of your product to temperature changes, because it could result in a loss of stability. For instance, if your water activity is good at 25 C but not at 40 degrees C, then if that sample experiences abuse conditions during storage or during transport, then there's the potential for it to have problems or lose stability. So with this system, you can actually change that temperature that you're reading on the same sample and see exactly what the impact is of temperature on the water activity and see if it could be a potential problem for your product. So because of the Neo's ability to be able to control temperature over a wide range, it scores a 10 out of 10. The next element that I want to discuss in terms of water activity instrumentation is data control. So of course, you generate water activity values. You need to have some way of being able to preserve those readings. With the LabMASTER NEO, it is completely 21 CFR Part 11 compliant, meaning that it has the ability to be able to secure all data. It can restrict the users. It provides an audit trail right on the screen that you can access at any time. Offers a barcode reader that can be used with the system. It can be interacting with a LIMS system and actively putting data into a LIMS system. Also has a software that can be used with it to collect data off of it. And each data point that's taken on the instrument is stored. It can store thousands of data points on its internal memory. And any of those data points can be accessed through an included SD card, or it can be, again, attached to a computer to collect and get that data. So in terms of preservation of data, meeting requirements for data control, the NEO scores a 10 out of 10. So in summary, after going through all of these key elements in terms of water activity instruments, while some other instruments would score high in any of these elements, the unique thing about the LabMASTER NEO is it scores the highest in every one of the elements that we've discussed. And it's really the only instrument that, that can be said for. And so because of that, because of the high scores it achieves for accuracy, ease of maintenance, difficulty of verification, hysteresis, the seal of the chamber, the ability to adjust the equilibrium settings, the ability to detect true equilibrium, ability to read any kind of sample with volatiles, the temp control range, and its ability to control data, because it scores high in all of those areas. In my review and in my opinion, based upon all of my experience in working with water activity, the NEO is the top instrument available in the marketplace for doing everything that a water activity instrument should do. And with that, I appreciate your attention in this video, and have a good day.